I'm so excited to have you all here to kick off ACT-W Conference 2021.
My name's Sarah, and I'm going to talk to you about predictive maintenance. It is the idea that we can predict when something is going to break before it breaks.
I'm excited to be introducing today's session with Monica Tamboli.
Thank you. I'm so excited to be here. And today we'll be talking about microservices.
So my topic is going to be about pioneering a process improvement team. And process improvement, in my opinion, has always been a change management technique.
We all deserve an inclusive, supportive, and encouraging work culture. We deserve encouragement as we pursue and move forward on our tech pathways. For you, with you, and for the future of tech.
Amazing.
Everyone, good morning, afternoon, or evening, wherever you're joining us from. So excited to have you here with us on Learn TV today for the ACT-W Advancing the Careers of Technical Women event. You might be wondering what this ACT-W thing is. Well, it stands for Advancing the Careers of Technical Women, and it's brought to us by an amazing organization called ChickTech. ChickTech is the nation's largest nonprofit organization focused on growing and retaining people of marginalized genders in technology. And let me tell you, this is something that is so relevant and important for today. So you might not know, but every year, Stack Overflow has an annual developer survey. They just released the results of their survey for 2021 the other day, and the results are kind of astounding. So about 91% there of all respondents and 92% of professional developers in the survey say they identify as a man. So that's an overwhelming number, and that's why organizations like ChickTech and ACT-W and their missions are so vitally important. This is an organization and a cause very dear and near to my heart here, so I'm very honored to be hosting the event today. So what do we have in store? Well, each year the ACT-W conference brings you together women of all different backgrounds, technical backgrounds, for a conference to participate in engaging sessions, workshops, and networking. And that's what brings us here today. We're honored to have three of the guests and speakers from the ACT-W conference this year with us today on Learn TV. We have Sarah Ewing, Banu Burham, and then Monica Tamboli. So in the next hour and a half with you all, we're going to discuss the ACT-W conference, and we're going to go deeper into each of their three sessions there. We're going to have some open discussion and Q&A with some of our cloud advocates here at Microsoft. So again, super happy to have you all here. And yeah, let's just dive into our first segment here. So we have cloud advocate Cassie, and she's going to be talking with Sarah Ewing about her session on predictive maintenance use cases.
Thank you so much for that amazing intro. I am super excited to be here. I'm extremely passionate about diversity in tech. That statistic of 92% identifying as male is one of those things that shows the importance of events like this and why we're here today. So as you said, I'm Cassie Brevu. I'm a cloud developer advocate at Microsoft focusing on AI. And I am here with Sarah, and I'm super excited to talk about her session because I got to watch it and it was awesome. So why don't you tell me a little bit about you, Sarah?
Well, my name's Sarah, and I am a data scientist. I really love data, and I'm really passionate about it. I also run a meetup group, and I have a podcast called Sarah in Tech.
That's awesome. So in your talk, you talked a little bit about predictive maintenance, which we're going to learn a little bit more about. But first, let's talk about how you got started in data science. There's a lot of different ways to get started in data science and tech in general. And there may be people watching now that are kind of interested in starting this journey. So I would love to hear more about yours.
Well, my story is probably similar to a lot of people in that I didn't start out in tech. I've never taken a programming class. It's kind of been a winding road where I started out in biology with endangered turtles. And I realized while doing experiments, not hurting the endangered turtles at all, that every time you did an experiment, you had to do statistics and you had to do a p-value and everything. And I already loved math. So going down that path even further, started taking stats classes in undergrad and realized that I love statistics. Unfortunately, or fortunately, you have to learn to program. So I did eventually learn to do that on the way. I ended up getting a master's in stats and realizing that big data statistics, while not entirely data science, definitely steps into that realm. And I found it fascinating, like, what do you do when you have so much data? And I just really love the data science space.
That's awesome. I love talking to other people with non-traditional paths because I think they're really inspiring, because there's kind of a stereotype of you had to get a computer science degree. You had to be like programming since you were 5 years old. Like there's like all these kind of stereotypes around it, which are really not true. And so I have a non-traditional path as well. And I started, like, I wrote my first code in Excel with VBA macros. And so like if you have an interest in something, you just have to try and start. And I think one of the biggest ways that we can actually counteract some of these stats that we're seeing is by career switchers like you and me. And I think they bring a really interesting perspective into the field as well. People that switch careers and kind of are coming in because you bring all that prior knowledge, like all that biology knowledge is super probably useful and impactful in your day-to-day work as a data scientist. So tell me a little bit more about the role of a data scientist.
So it's not just the cool part where you stick ML onto data. You, unfortunately or fortunately, have to spend 90% of your time cleaning the data, getting the data into a place where you can actually do data science to it. And so there's a lot of other hands that touch it before it gets to me. It has to go into a database and all of that and be put kind of into a structured table, if you will. And then even after that, some of the data it isn't clean. So you have to go in and clean it, explore it, mine it, see if there's any trends going on it. And then after all of that, you can do the fun machine learning and AI and all of that. And then afterwards, you do the production and the GUI interfaces and all of that. I've been involved on all of these different levels. So it's a very diverse field. It's not just going in, combating all of it and throwing the model in. It's very wide.
That's true. And a lot of the tutorials focus on building the model when so much more of it is getting data, processing data, cleaning data, and making it ready for training. So that's a really good point and something that I think many people don't realize. And also, it's interesting that you've done the full kind of like all the different roles that go into building a model, because a lot of people kind of specialize in one kind of area of data science. Or of the model building process, I should say, from, collecting data to cleaning it, to processing it, to building models, to doing like ML ops and production. So you've kind of done all of those different roles. Can you tell me a little bit more about each and the ones that you've done?
So I don't put the data in the database. I'm not good at data engineering yet. But one day I hope to be. So that's the person that puts the data into the database, makes sure that the database is balanced and doesn't fall over, if you will. But after that, creating all the sign-ins and logons into, I think I've worked with over 10 to 15 different database styles, and pulling the data out and cleaning it and exploring it, that's actually very time consuming. It's like, can the height of a human be -1? Probably not. And so you just have to use common sense. But looking at millions, billions, I've worked with well over 6 billion records for one data set. It's very difficult to deal with. But you have to kind of use common sense. Like, can you make a purchase that's negative? Yeah, you actually can. It's when it gets refunded. But sometimes you have to work with subject matter experts to come to these conclusions that that's the transaction that was there. So there's a lot of different things going on in that space, and it's very time consuming to clean, explore data. And I would say that is most of my job. And I honestly love it. I love going in, cleaning, and exploring. The actual model building sometimes makes me nervous because you don't always know if you can make a model predict what's going to happen in the future. But I know 100% that I can clean data and I can go in and mine it and explore it and graph it. And so it's just time consuming.
Yeah, and I think if you love that side, you should definitely start getting into databases. I took a SQL class like a long time ago now. I've done a lot with SQL, but I loved it so much. I was like, maybe I want to be a DBA. So it's interesting that I ended up in the data science because I've always loved data and working with data. So being a data geek is definitely something that is helpful in this field and with building it. So that's awesome. And I also like another point that you made is that you can't always get a good result with the model. And there's also like this good enough kind of idea. So how do you decide if a model is predicting good enough?
It honestly depends on the field and what's going on. In certain scenarios, good enough is, saying that the roller coaster is going to break before it breaks, because there's so many safety features built into it naturally, you're catching 25 to 50% of the breaks before they happen. And then the other maintenance that's regularly done, it goes in and does it. But like in other things, like in a nuclear power plant, you want to catch all of the breaks before they happen, even though you have the A, B, and C plans in place. So it's really depending on who you're talking with and how they deal with a break in that space. And to drop some jargon, it's precision and recall and accuracy and all these different things that go on. And you have to make sure you are delivering what your customer wants. Customer being like the end user and what they expect to see out there. So there's a lot of working with people who are experts in their field to try to figure out and build a model that's intuitive to the way that they want it to behave. Because as a data scientist, if I come in and put a model in, it's not intuitive to the way that the field operates. And I've worked in everything from ag to fraud to nuclear power plants, roller coasters, and servers. So I've been all over the place, and it's been a lot of fun, and I've learned a lot of different things.
Yeah, and let's talk a little bit more now about that predictive maintenance, because you were talking about some of those models that you've built and kind of how you had to decide whether they were good enough and working with the customer, and kind of sometimes it's about helping them understand that something is good enough too, because I think a lot of times in programming we think it works or it doesn't, right? And in machine learning, it's always like, I feel like it's more gray, like it works good enough. So let's talk a little bit more about predictive maintenance and what it is and some of the different things that you've built with it.
So predictive maintenance has a silly name because it's predicting maintenance. You want to say something breaks before it breaks, so that way it can be fixed in the natural rhythm and flow of the environment that it's in. So for roller coasters, you want to fix them in the middle of the night when no one's riding on them. And for different machining plants, you want to fix it between different shifts when no one's actually operating or creating product. On servers, you fix it when a job isn't running and you have to purposely like block it off and be like, don't go on the server. And so it's very different for each field. It is basically the main story about maintenance and predictive maintenance and how it's defined. Usually all of these different fields have planned maintenance that already exists in it. And the idea is that we're going to save human hours by reducing the planned maintenance. So, every single day someone goes out and checks the brakes on something. Rather, we're going to put an edge device that actually checks the brakes for a human. And when we see that the brake isn't behaving in the perfect way, someone's going to go out and check it and do the maintenance then, rather than spending 15 minutes every single day to check every single brake. So it's definitely the goal is to save human time and increase customer experience or production time, what have you, for each discipline.
And in the roller coaster, safety too, right? So it's not only, it's like there's a safety side of it. So we're actually making sure that we're making things better. I have a fear of roller coasters. And so during your talk, when you were talking about the roller coaster ones, I think my hands were getting a little clammy. And I was like, and this is why I don't go on them, because they break. But they don't, because there's people like you building models and maintenance people going out there making sure that they're safe for people to enjoy being terrified for some reason.
It's the adrenaline.
It must be. It's got to be something. And maybe I just have to get over that fear and then understand that it's safe and that like rushing towards the ground is fun for some reason, because you don't die at the bottom.
No, you don't. They're very, very safe. Let me stress that. And then the maintenance algorithms are very, very accurate. So it's very important to stress that, especially with nuclear power plants and with roller coasters. They have an A system and a B system and a C plan. And then on top of it, they have predictive maintenance. So the idea is that you will be safe.
That's good to know. So the predictive maintenance is on top of like multiple backup plans. So you were talking about sensor data and IoT Edge, and I've been playing with this Azure Percept I have over here, which is an IoT Edge device that has a camera, a mic, and a board. That makes it easy to build. So I want to hear more about some of this IoT sensor data and what are do you know a little bit about the architecture, what kind of sensors they're using, or kind of like what's your experience with IoT Edge and AI?
So my experience with the IoT Edge and AI is different for each application. It depends on what you're monitoring, whether it's a vibration sensor or a video feed to make sure the temperatures on everything are within the appropriate bounds. So you do thermal scans regularly with cameras. You can do LiDAR to see like the depth of where things are and to make sure things haven't moved. There's analog sensors saying like, it's at 3 or it's at 5. And there are other sensors. A lot of what I worked with was binary sensors. So a lot of ones and zeros at the millisecond level, which, it just like your eyes glaze over when you just look at a screen of ones and zeros. It's normal, but turning that into something that's actually meaningful is really fun and cool. You wouldn't think binary data is like the cool data, but I'm like, binary and vibration sensors, like those are my jam. Okay.
That's awesome. I imagine like cleaning the data and normalizing it is a bit easier as well because you're already dealing with ones and zeros and that. So is it more, what's kind of the hard part obviously there's lots of hard parts, but what is like the harder part? Because for me, I'm dealing with like a lot of sometimes like natural language processing or images, and there's a lot of process to get it to the point where it's ready to be put in. So what kind of cleaning do you do on the binary data? Other than like invalid values. I know we talked about that a little bit already.
Yeah, no, you're cool. So what happens is every single millisecond they come in and they say it's 0, 0, 0, even if it doesn't change. And so dropping that down to a timestamp and just like a 1 or a 0 when it actually changes is one way to look at quite a significantly smaller amount of data, and then actually aggregating those values out to the hourly level or to like 10 or 15 minute levels and some sort of metric, which is kind of the secret sauce to everything that goes on, is the way to go because looking at the binary data at that level, it's not too meaningful. You can't just shove that into a model, unfortunately.
Yeah. So then what kind of algorithms are you using on that data, and kind of what's your process of picking and going through your hyperparameters? And I know we're getting into a little bit of a jargon here, so maybe we should explain what some of those things are as well as we talk about how we would do that.
So at the algorithm level, if you will, I'm assuming you mean from like, how do you do, we call it the change table. So the ones that actually transition into an actual aggregate, you look at like how many times it actually transitions or other sort of metrics at that point that start being correlated to what we call the ground truth, or where the maintenance actually happens. And we have to have some historic data. We can't just go in, put the sensors on and be like, okay, Sarah, let's put in some machine learning. I actually need to see some maintenance data alongside the sensor data so I can see if there are spikes or drops in certain metrics and hook that up. And we call that the ground truth. But a lot of what it operates in is kind of an unsupervised space. Unsupervised being like, hey, I have a bunch of, like in a y equals mx plus b type setting, you just have a bunch of X's and you don't have any Y's, and you kind of have to check your answers against the correct answers in the maintenance log. And there is NLP in this space. Doing fuzzy string logic, because someone goes out and says, hi, I looked at the server and it was behaving weird, and half the time I have to be like, hey, who was the guy that did maintenance last night? I don't know what the server is referring to. Can we like start putting in like the server numbers, and then you have to use fuzzy string logic, like what server is this matching closely to in my naming lexicon. And so there's a lot of different steps that you go through. And so it isn't just very straightforward, like throwing machine learning on. Most real world problems with machine learning and data science are horribly complex, and you're trying to shake out the noise and find the signal in it. I like to think of myself like a data detective, if you will.
I love that title. We should change that to data detective, like, because you're finding, you're like, how do I take all of this information and make something useful? How do I clean out the noise? It's interesting to think about the notes that you have to go through and kind of make sense of those as well, to correlate that to then your data to then help with those predictions. And I think, so when we do a lot of the tutorials that you see, I think are supervised learning. You mentioned unsupervised learning. Can you tell me a little bit about what each of those are?
So supervised learning is a fun space as well as unsupervised, in which you have, I keep going back to like y equals mx plus b, but you have the answer key, so you can train the model and tell it to go out and behave in a certain way. In an unsupervised space, you don't have the answer key, and so it's like going out and taking a test and turning it into the teacher and asking them to grade it for you to see how it does. So you can't do a one-to-one match. Is what happens because we know maintenance happens here, and we want the alarm, depends on the customer, to happen within a certain amount of time before the maintenance event actually happened when you're training it. And so you have the algorithm go out and say, here's an alarm, and then you go check the answer key. Oh, someone performed maintenance, or it comes back and says, here's an alarm, and you're like, there is no maintenance event that is associated with this. You're a bad algorithm. Go back and think about what you did.
You need more training. Go back to the GPU server and learn something new. That's our jobs, data scientists. Go, you're in a timeout. No, I'm just kidding. That's where the moms are. Like, we're both moms, so it's like that's where the mom comes in, and there's like the machine learnings are like our little babies that we're training. That's what I think about when I'm building things. Cool. So that really gave us a better idea of some of the ways that you go about building, and some of the difficulties in it as well, dealing with these large data sets. And a lot of those you can't fit into memory either. So you're dealing with probably like a subset then of that data, or are you doing parallelism, or how are you handling these large data sets?
So it kind of depends on the problem that I'm working with. I've used multi-threading. I've definitely used Spark quite a bit. And then you can do different sampling schemas, because usually you can't graph things in Spark. And so you have to try to sample things correctly, which in and of itself is a whole host of problems. How do you sample 6 billion records and do it accurately to represent the whole data, because pandas can only hold so much, and it's not even a fraction of what's there.
Yeah, and I want to invite people that are watching to ask questions in the chat too. I'm keeping an eye on it, so I'm getting all my questions answered, and now I want to do a predictive maintenance problem. Is there like a hello world or like a resource or something if they're interested in learning more about building predictive maintenance models that you would recommend?
So my favorite thing that I've worked through is Manning's Deep Learning with Python book. It was the gentleman who actually created the Keras package for Python. And I found it insanely helpful in focusing a lot on time series techniques. There actually isn't a predictive maintenance book that I've found. I've worked through quite a few books, but there's a lot of self-teaching, and definitely had it on my brain to write a book for a while now.
Oh my gosh, that would be amazing. I've done a little bit of time series, and when you were talking about the timestamps and the predictive maintenance and all of the data, I was kind of thinking back to some of the things that I've used in different time series things. So that would be another thing to look up then when you're thinking about predictive maintenance, would be looking up how to do time series problems. And I think half of learning and understanding different things is knowing the right words to Google in Bing. Mm-hmm. And so,
I mean, if I didn't have Stack Overflow, and most of the programmers I know didn't have Stack Overflow, I think we would be lost, because we use it all the time to how do I do this programming thing, and go out and kidnap some code.
And if you switch languages a lot, I switch around and do a lot of different languages, sometimes the syntax, you write the wrong syntax in the wrong language. And so let's talk a little bit about languages. What is your go-to language, and what's the main ones that you use in your processes?
So my personal favorite, I might get a boo from the audience, is R. I love it.
I'm just kidding.
But I do... Don't shoot. I do use Python regularly. SQL is an absolute must. You cannot function in this environment without knowing SQL. And I know SAS, but some people might not be old enough to know what SAS is. So statistical analysis software, but that's from my stats days.
Cool. Yeah, I do more Python. I think there's more community around Python. It tends to be more popular. and then using like libraries like TensorFlow and PyTorch. So I could keep talking about this with you for hours, but we unfortunately don't have hours. So I want to thank you so much for being here. And I think, yeah, I can't ask any more questions. So thank you so much.
Thank you so much for having me. I really appreciate it.
Oh, well, thank you both, Cassie and Sarah. And I love that term data detective, first of all. And then like the fact knowing that predictive maintenance is keeping me safe on roller coasters makes me feel a little bit better. So thanks. Thank you both for that. And make sure to check out Sarah's podcast too, Sarah and Tech. So, all right. Well, now it's my turn. I get the pleasure of talking with our next speaker here. Let's welcome Banu with us here. Hi, Banu. How are you doing?
Hi, April. Very well, thank you. And thank you for having me here.
Awesome. Great to be here. So you did an amazing talk on pioneering process improvement team at the ACT-W conference. So why don't you tell everyone first a little bit about yourself, your background, what you do, how you got started in tech, and then about your session.
Yeah, for sure. In terms of my background, I started off in a process improvement team in a fintech company here in Canada, Toronto. And after that, I slowly moved into IT and software development. So similar to Sarah, who started off in a different domain and moved to something else, my career path has kind of taken me towards just improving things, innovating things. And today I'm working in the central strategy team with Infotech Research Group as a central PMO office. In terms of my talk itself, I wanted to introduce the mindset of process improvement to our audience. I wanted them to understand that it is not necessarily a toolkit that you just pull out when something is wrong, but it's really an ongoing process that you think about both in the short term and long term, depending on what your final end goals need to be. And really, innovation is not something that has to be high tech and cool and have the latest technology in there, but it's really just those small stepwise improvements that you make to make your job better, to make the final product better, to make your user experience better, and can be applied to a myriad of fields. And essentially, the talk was just to introduce the thinking. How do you pilot a team that thinks about process improvement? How do we make something better for tomorrow compared to what we are at today?
That's great. This kind of leads me, I'm kind of like to see what the audience who's watching thinks about this, but you mentioned like, innovative companies, maybe like having better technology. So I'm kind of curious if we could do a quick poll, maybe, what do you think, people watching? Do you feel like innovative companies have better technology? Like, yes or no? I'd be curious to see what you think there, because I kind of.
Yeah. So yes, as you said, I would be very interested to see what the audience has to say. But apart from that, in my personal experience, because of how technology has really enveloped our life in different frames and different, aspects as well. Like a couple of days ago, I was attending another conference and someone was telling me how their kids are so used to having Alexa at home. They might not even miss the parents, but they'll miss Alexa if she's, unplugged. So it has really enveloped our life so much that people don't necessarily distinguish technology from innovation in general. So they tend to think that, if someone has better technology, they're probably innovating more. But a key distinction is that if you don't even think along the lines of saying, hey, I'm remembering a simple example, I'm finding like remembering my appointments very tough. I don't want to store it in my head. I actually want something that will remind me. And then you move on to a technology platform. Today, all smartphones come with a calendar and reminding application, so you can use that. But really, to even move from that thought process, and I'm guessing going forward, the next generation, because they're so used to their smartphones, won't even be in a situation whereby they'll be thinking, I need to remember my appointment. And you'll be like, you remember your appointment? My phone reminds me. So they might not even be in that boat anymore. So definitely, I think the newer generation is more attuned to technology, and therefore, they might not be thinking about some of the basic problems that we might have gone through in our generation, like maybe 10 years back, but they will be innovating more than that. So yes, technology does push us forward to a certain bit, but that mindset that comes along with that, that is something that all companies have to adopt in order to be technologically advanced to begin with.
Yeah, that's so true. I just know for myself, like I was remembering the other day, like I don't actually know anyone's phone number. It's just saved in my phone anymore.
Exactly.
Like what my own husband's phone number is probably. So yeah, great point there. So one thing I was wondering is, like development oftentimes, right, is dealing with really technical setups and solutioning and what business asks us to do as developers. So what exactly as developers can we apply process improvement towards?
Yeah, a great question. I find that developers are actually in one of the most key seats to suggest process improvement to begin with. And the reason for that is they have so many tools and methodologies available in their head. They're really proficient at what they do. And therefore, they're able to say, so for example, if I know that a hammer can actually drive a nail into the wall, and I see a problem in front of me whereby a nail is actually stuck out of the wall, I will remember that, hey, there is a hammer that I can use to push this through. Meanwhile, someone who doesn't know the existence of a hammer won't even think in that direction. So I feel that as developers, you actually have the toolkit to suggest a lot of improvements that can be put into the dev environment or in the organization in general. So the first thing that often comes up in my conversation is tech debt. It's one word that everyone kind of stays away from because it's not necessarily fun. All you're doing is like, it's basically the previous panelists that we were talking about. It's a lot about the maintenance side. We want to make sure that people are safe and things like that. But it's not necessarily the most fun activity. After all, you're topping up the oil or you're fixing the brakes and so on and so forth. But tech debt, when you actually think about ways to do predictive maintenance, or if you are able to detect what are some of the things that you need to continuously change or keep your eyes out for, and when you make those improvements, you can see a market improvement in the output because you've actually fixed a lot of the basic underlying issues that helps you propel yourself forward in terms of the code base, the code quality, and things like that. So that's one area. The other area that I can think of is algorithms, just simply coming together and thinking through the solution. What is that we have to do from one step to another? Referring back to some of the user personas that you might be receiving as part of requirements, or receiving, looking at some of the test cases that the QA team may have built, looking at some of your system unit tests that you may have written as well, and think about what the algorithm procedure is and what the process would be like to provide a better user experience on the whole. And it's not just the end user experience, but think about yourself as a back-end developer, as a client-side developer, as an HTML developer. What would be easy for you to maintain this code going forward? Do you actually want clunky code, or do you want something that's done neatly? So even writing the code itself is an art. You want to be minimalistic as much as possible, but achieve maximum effort. How can you think about that? Solution architecture, that's another area. You can reduce the number of calls that a system is making. How many API calls are you sending out? The time it takes for some of those response times, can you minimize that in some way? And minimizing some of the error scenarios as well. If you think about the end case, the user needs to know why something was not successful on the screen. So if we give them like an error that they can't really decipher, they're wondering, what does this error tell me? Or in some cases, people actually provide a code on the error scenario, and when the person calls the call center, they're like, oh, this is the code. Now I know what needs to be done. I can actually diagnose this. These are simple ways that you can actually improve even on the development side. A BA or a product owner or product manager doesn't need to come up to you and say, I want a user-friendly error message, but this is something that as a developer, you can think about the end client and kind of say, okay, this person is calling the call center, they'll need some sort of context as to what happened. So helping them with the process flow. Some of the other things that generally developers work on is code refactoring. If you have written a code about 5 years ago, every language is evolving. We closed off the previous discussion talking about different languages. There's R, there's Python, Java, C, C++, so many different languages, and every language has its own pros and cons. So when you learn that, in a certain language you're able to do something, think about whether or not you can apply the same thing in your existing systems. Maybe something did it very efficiently and elegantly, and are you able to bring that over? And that's the concept of refactoring, making sure your code is updated. If there are new error scenarios that you need to reintroduce, those are some ways that you can think about. Code reviews is one of my favorite things. It's almost like your Amazon product review or book reviews, right? So if you have done something and you want someone else's feedback on how well you've done it, you would basically take that and give it to someone else and say, hey, can you take a look at my code? Can this be done in a better way? And that way we slowly improve the quality of code that we have in the system as well. And handovers, that's one of my favorite things to talk about, because often the developer would have done something, they would have submitted the code, and the QA will not even know that something was ready for them to take and start testing. So how do you improve those communication aspects and communication scenarios? Always going back to the requirements and understanding whether or not you are coding for the right thing. Are you building the right solution? Being more attuned and connected to your end users is very important in that case, and that will automatically help you improve a lot of things, because at the end of the day, you're trying to make their day better. And last but not the least, having explicit ownership for things is very important. Sometimes what we do is, hey, you know, I'm doing this code, but this is not really my area of responsibility to make sure that the code quality is done well. All I'm responsible for is a chunk of code that I've submitted, and therefore I'm not going to look at anything else. But instead, if we promote that concept of, hey, you know, I will take this up because this is, you know, I'm interested in this. It helps with your career progression. It helps with your leadership skills. It helps with, you know, gaining more perspective of the high level view of how the code is set up, how it should be improved, and so on and so forth. So that would be my, you know, those would be some of my suggestions as to where you can start looking at process improvement.
Yeah, that's great. You know what? I really liked your earlier point about developers kind of being, you know, uniquely positioned to help with these process improvement teams, because we really do. Developers tend to have that debugging, that troubleshooting mindset, and that's what you need, right? To really, you need that mindset in a process improvement team to really figure out the best solution. So that's really great story. Yeah,
wonderful.
And then technical debt too. I mean, we all face that. So kind of speaking of that, and along these lines, you know, so we can't talk about process improvement without talking about documentation, right? So that's a big part of it. So what would you say to those watching that maybe they don't feel like they have time for this extensive documentation? What can they do about that?
Yeah, I come from a BA background in the sense I love writing documentation. And if you go to my LinkedIn profile, I've written a lot of blog posts as well. And that's simply because I enjoy sharing and I enjoy writing. And I'm totally acknowledging the fact that not everyone is going to be in the same boat. And they might be like, hey, I'm the person that uses contractions in chat. And if I cannot talk and I can just record my message, I'm going to go for that. So yes, documentation is something that people are not necessarily interested in, not everybody. But what I really mean here during my talk when I was talking about documentation is specifically focusing on what you need to write down and what is it that you need to communicate. It doesn't need to be very different from your verbal communication. Like if you're talking to your boss, you're not going to give them like a 20-page essay of, you know, this is how this button works. But it's really highlighting specific pieces and saying that, you know, these are the aspects that we need to focus on and these are the things that we need to look at. So really focusing on understanding why is it that you're documenting something. So it doesn't need to be very extensive. And especially if you think about the agile environment, you're really looking at specific formats. As a user, I want to, so that, you know, a simple context that gives you the business case behind it, what you're trying to achieve. And then if you need more details in terms of functional requirements, personally, I usually start off with the epic, the user story, and then I go into some functional requirements. And then at the end of it, I make sure that my acceptance criteria kind of covers everything off. So it's really to initiate the thought process behind it rather than writing something down for the sake of writing it. It's not to create more red tape. The other thing that I recommend when we are writing documentation is capturing some of the key decisions. And the reason I say that is we're moving into a product management type of world whereby everyone wants to understand the whole concept of why we are building something. What is the value behind building something? And when you're thinking about the value, you cannot shy away from the why aspect of it, the pain point, as you mentioned, the debugging. You know exactly where things are going wrong. What is the pain that we're trying to solve? And key decisions often tend to be lumped along with those pain points because you might be like, oh, you know, I've got 5 different pain points here, but I'm not going to be working on 3 of them. Why? Why am I not working on those? Why is this not part of my MVP? Versus these other two items, I am going to be working on them because they seem to be the biggest pain points, and this is the reason why. If you get some sort of executive decisioning behind it, if you get some sort of feedback in terms of saying this is key because this kind of maps to our company's mission and vision, this is mapping onto our key metrics, this is going to impact our bottom line, those kind of aspects are very important in capturing the key decisions. And the reason I say that is because, you know, we will be evolving over a period of time. time. Nothing is going to be consistent. Even with process improvement teams, there are short-term goals and there are long-term goals. And maybe in the long term, we realize that the why that we initially started off with doesn't hold true anymore. For example, back in the day, people used to think, oh, after every update that I do to a specific code, I need to write out my name to say that I was the one who did this. But today, when we're talking about user provisioning, user IDs, and using the whole concept of Azure and making sure that people are all set up in the system is automatically able to pull the person who made that change. So in effect, if your process still says you need to sign the document at the end, it doesn't make a lot of sense because now the system can pull it up. So understanding the why behind these key decisions. And then last but not the least, understanding some standardized documentation as well. I am a big fan of living documents, and the reason for that is it helps with onboarding. It helps with some of the standardized structures. If you're looking to get some sort of certification like with ISO or CMMI, it really helps with that. Last but not the least, it really puts the power onto the hands of people who need to start using it and implementing it. So, for example, often a lot of times what happens is the business might come back to you and say, hey, for error 101, the error message today doesn't make a lot of sense. Can you change it to something that's a bit more business friendly? Being in Canada, we also need to support English and French across all provinces because we've got 2 official languages. So when you think about something like that, or even Microsoft that kind of works across so many different countries in the world, and every part of the world has their own restrictions on languages, think about making the error messages content managed. Again, this is part of the documentation, but simply by pushing that part of empowerment to the business owners or the product owners or the people, the linguistics department that's actually doing the translation, you remove a whole layer of responsibility from yourself. You're not going in to make these tiny things, and now your development team is actually empowered to make more innovative changes in the system rather than going in and fixing an apostrophe or adding in an extra the in the sentence or whatever that is, right? So thinking about documentation that way, in the sense that I will do what I need to do, but anything outside of that, let me empower the people who need access to it, and therefore I remove myself, free up myself to do something better.
That's great. So I'm admittedly one of those people that kind of, I dread documentation and having to do that. So it's kind of good to know that it doesn't necessarily have to be like a big thesis level, documentation. We can keep it kind of high level executive summary, focus on the pain points and all of that. It doesn't have to be too daunting and overwhelming. So that's good to hear. So we talked a lot about, process improvement, how we can do that. Now let's focus on what are some tools really that we can use to help us with our process improvement.
Yeah, for sure. So there are lots of process automation tools that are out there in the market. So if we do a simple Google search looking for RPA tools, these are going to come up. In fact, one of the tools that I recently discovered was part of Microsoft Power Automate, which was called Process Advisor. And often what happens is when we're looking at digitizing these processes, we need to sit and kind of job shadow every person who's doing the task, ask them to grab screenshots, put them in a document, maybe sit there and time them to find out how long does this take for them, and multiply that by maybe 1,000 applicants, or maybe the number of tasks that they're doing, or how many times they're doing the same thing. And then based on that, we even start looking into some of the automation. Like in the previous panel talk, we were talking about automation using data. How do we build these models, and how does it automatically build some of these things? One thing I do want to caution the audience about is that when you're trying to automate something, always try to implement that manually first, because you need to really understand what are the exception flows, what are the alternate flows. Are we able to handle it in a manual way first? Maybe test that out. Like I said in my talk as well, piloting is one of my favorite things to do, because it really helps you identify all those little changes you need to think about, all the things that you didn't necessarily think about on paper, but in real life they do happen. So think about manually doing a specific process, and then try to digitize that to see how technology can assist you as a tool base. That is not the main, like every technology is not going to solve all the problems out there in the world. If that was so, we wouldn't be having a lot of pain points, but technology is a tool for you to enhance what you're trying to do. So once you have done things manually, you can look at some of these RPA tools as well. And like I said, with this Process Advisor, what that does is pretty cool, that you would go into the screen that you're trying to work on, you click on the specific steps that you go through, and it provides you with, a walkthrough of all the steps that you actually did, the UI pieces that you clicked on the screen, and then you can use that, and it tracks the time as well. And then you can take that and kind of do an analysis of how long it actually takes you. And if you multiply that by 10,000 times, that's the number of applications you get. It's really easy for you to analyze how quickly these things can add up. And the benefit of automation, therefore, right? So when you're doing these process improvement activities, when you're trying to innovate something, you track the time that it actually takes for you, and then you see whether or not there is an ROI. Is there a return on this investment? If I automate this process, in fact, I'm trying to do something right now at my workplace, trying to automate something. And I know that every month I take about an hour, 2 hours to get the things together. So for me, if I know I'm doing the exact same step every month, why not automate it? And I will save 2 hours, and I can put that towards something else. And even, transferring the ownership of this process is going to be easy for me, because I just have to tell them, hey, click on this button and everything will be done for you. So you don't need to worry about it. I've assigned an owner, but they don't have to go through the painful process of going through it. So yes, then one of the resources that I provided, one of the links there is softwarereviews.com. It provides a list of all the different kinds of automation tools to your question. And you can use those tools to monitor and assess whether or not it's a good fit for you, and understand the why behind you're trying to do something like that. Is it because you're repeating the process? Is it because it's something that you can track online already, like submission of forms instead of using an email, creating a new line in some sort of file, which again can be done by Microsoft Power Automate. So thinking about the why will help you quite a bit in terms of shortlisting the tool that you want to use for that specific purpose as well.
Yeah, that's great. I love that you said, first of all, to do it manually first before you start trying to automate it or use any of those tools. But I especially love that you did mention Process Advisor. Being in the Power Platform space myself, when it was just released in general availability just a month or so ago, and I had to get my hands on it as soon as I saw it, because I think it's so huge for helping us with our process improvement techniques and being able to really see what our process is and analyze that deeply so that we can figure out the best way to improve that and use it along with the RPA functionality with Power Automate desktop flows and all of that. So super powerful, definitely a good tool to have in your tool belt there for your process improvement scenarios. So well, all of this has been so great. And, I really think sometimes the hardest part of anything is just figuring out how to get started, right? So beyond some of the tools that you just mentioned and all the great advice you've given so far, are there any additional, links or things that you would suggest for people that want to get started with this?
For sure, yeah. In the resources that I shared, one of the things that I personally like is getting a quick intro about Lean Six Sigma. It is a toolkit. It changes the way you're thinking about certain things. It really drives you towards that whole concept of what is the value behind something. And I think in our audience, I'm assuming there are going to be a lot of newbies as well who are coming into the development space. They've done a lot in school and they're really excited to apply all those skills in the practical world. And yes, I've done that transition as well. Like in school, everything seems perfect. Data sets seem to be perfect. Environments don't have any errors because we are working in a very controlled environment. But real life is not like that, right? So as you're going through some of these resources, you have to think about how do you want to improve and apply these things in the real world. You want to think about what are some of the barriers that you will have to cross that wasn't necessarily covered as part of your course material. So to give you an example, how do you account for human error? What do you do when someone is willfully maybe entering the wrong information in the system, or someone who is willfully bypassing a certain process because they feel that this is too much of a red tape that they don't want to deal with? And because of that, what happens in the process? How does it break down? And you really want to think about the human aspect that often we don't necessarily get a lot of exposure to in pure engineering courses. At least I felt that way, because a lot of times we were talking about voice of customer, but our test subjects were often just our own classmates who didn't really want to jeopardize our project, right? So they always give positive responses to our work as well. So it's really hard for you to apply that in a practical world, and you have to think about the different human elements in there. So Lean Six Sigma really gives you a lot of aspects in the toolkit about how do you probe the user to find out what the underlying cause is. For example, the fishbone diagram, the quality functional diagram, which is basically identifying what are the different aspects of quality are you measuring a specific product against. And what is the weightage that the audience actually puts against these items? And therefore, what are the specific product features that you need to focus on? In fact, I find that a lot of aspects in Six Sigma, I was able to translate that over to the product management side as well, because it gave me a new way of thinking. I came with the background of understanding what is it that my customer wants. And I think that's the main pivot that a lot of new folks in the industry need to think about. Is it's not just about the coding aspect, which is a lot of fun because you're building solutions and you're learning all these new techniques, but you need to understand why you're doing something like that. And Six Sigma really helps you with that sort of thinking. The other thing that I want to highlight in the resources section is a diagram which is called the process improvement framework. And that gives you 3 different aspects. One is for software development in general, any process improvement framework, and process improvement framework specifically for software development. So that kind of goes back to a lot of the concepts that I had mentioned earlier about CMMI, Scrum, Six Sigma. Again, to your point earlier, April, it's going to be very documentation heavy because everyone has just sort of, it's been tried and tested in so many different environments that they want to give you the best information possible. But then as you're reading through some of this material, mark and bookmark those locations that you think are really relevant to what you're doing. And the ones that are not, put it on the parking lot or something like that, and then revisit to see if your department has actually evolved. You don't need to start with the entire toolkit the first day, but taking it bit by bit would take you much longer and farther in the process.
That's great. I think that's great advice for not just process improvement, but really anything you're doing. Start with why, focus on the why first, and then the rest will come. So yeah, thank you so much, Manu. This has been great. And everyone, be sure to check out the chat for all those resources that she did just mention, so you can check those out.
Thank you so much for having me, April.
Thank you. Okay, well, let's send it over to my fellow cloud advocate, Matt Sukup. He is going to be talking with our last guest that we have here, Monica Tamboli. Over to you, Matt.
Great. Thank you very much, April. Again, my name is Matt Sokup, and I'm a cloud advocate at Microsoft. And today, I'm really honored to be here. And I'm really excited to be talking about microservices with my new friend, Monica Tamboli. Hey, Monica, how's it going today?
Good. I'm excited to be here.
So I was able to watch your session from the conference, and it was amazing. But before we dive into it and talk about microservices, can you tell us a little bit more about yourself and about your background?
Sure. Once again, I'm Monica Tamboli. I work for IBM. Currently, I'm leading a test team, which is responsible for multiple products, including application server runtimes and some application modernization tools. So my team is responsible for having different kind of applications, from monolithic applications to microservices, to represent our diverse customers, as our customers are on their modernization journey, but at different stages. So we have to have a wide range of applications that way. So that was the motivation behind this talk. So talking about what I discussed in the talk in Act W session is, Matt, you would agree that these days companies' application software is under continuous demand to change, right? Let's take an example of e-commerce applications. They have to make sure, like, can you afford downtime? Probably not. That translates to millions of dollars. What about scaling, right? You have Black Friday events, you have Cyber Mondays, so scaling for those events. And what about the new features, right? We need the new features quickly, can't wait for weeks. So I talked about how microservices architecture might be able to help either modernize your existing applications, or when you create your new application, something to think about. Here, microservices mean where you want to have your applications divided into small, loosely coupled services, as opposed to monolith application where you put everything, deploy as a big chunk. So, and in this session, actually, I took analogy of a family, how over the years, our families have modernized or transformed into where, we earlier, it used to be tightly coupled families. Now we are more like moms are working outside, the men are helping in household activities, kids have their own responsibilities. So similarly, this is the approach for software applications.
Right, and I'm glad you brought up the like the e-commerce example, because I think that one's really easy to understand. Is that when you do have like your authentication and your login piece coupled together with your shopping cart piece, coupled together with, let's say, image caching, like if when in the monolithic sense, if one of those goes down, the whole thing is down, right? And where if you have it in microservices where you break them apart, and let's just say the image caching goes down, you can still keep your authentication and your shopping cart up. So,
Exactly.
and that's a really great use case for it. And
Definitely.
going back to the family analogy that you brought up, is when I was watching the session, I was thinking it's a great analogy on how everybody is like I guess the 1950s family, where everybody's kind of one unit, and they're going apart now to a bunch of different units, which is right. But I was thinking, well, how can I make my cat more dependent on me? He's totally, he's out there doing his own thing, but how can I make him, want to hang around me? But that's a totally totally different story. So, so one of the things that you mentioned was about modernization. Like, we're modernizing things. So I guess, can you elaborate a bit more about what you mean by modernization here?
Definitely. Let's think about as we modernize our old home versus buying a new home. So in this case, there could be different reasons. You want more energy efficient, it's not fulfilling your current needs. Similarly, something you need to look for your software applications, whether they are appropriate for your current needs, as we discussed earlier. So here, in terms of this discussion, we are thinking about probably, let's say you may want to move your applications to cloud. Are your current applications ready for that? So there are two approaches we can talk about. One is lift and shift, where you are thinking about operational modernization. You don't make changes to your application or even the runtime. You just take the same application, you probably want to containerize it and move to the cloud. The second approach is refactor. You want to refactor your code into microservices, as we talked about, where you create your smaller services, which are, again, independent. They can scale individually. So refactoring could be a great way also. And actually, I work on a tool which is called Mono to Micro. IBM has Mono to Micro, which helps you analyze your monolithic application. It takes into consideration your use cases. So you have to give all that data, your code, and then it analyzes to tell you if the classes, how the classes are being called and how they are in your application, to see whether it makes sense to split it into microservices, as well as if you have to split, how would you split, like which classes will go together in a service.
And that mono to micro application, when you were telling me about it, I didn't know about it before you let me know. And it blew my mind about that. You can just feed in your application, and all of a sudden it analyzes it, like you said, where all the method calls and so on. And it lets you know about how to partition it from your monolith or not. And yeah, that's super cool. And it's definitely something that folks should check out. We'll include a link to it in the notes for this episode. So going back to the lift and shift, so that is, you're going to just take your monolith, the existing application you have, where everything is just kind of bundled in one. You're just kind of going to bring that up to the cloud, essentially, or just kind of move that up to the cloud. And then is that kind of getting that one correct?
That's exactly right. And there could be reasons when you don't have resources to split your application to microservices. So this might be the first step. see if you move your application to cloud, you're still making use of like all your integrated logging, monitoring tools. So you have still one place where you have your infrastructure. So you are gaining some advantages, and see how well it works, and then slowly think about converting it into microservices. That's
Okay. So you could go lift and shift and then start refactoring, or you could just start refactoring right away if you wanted to. Really?
exactly.
Okay.
Yeah.
So let's say we did make the decision that we want to go to a microservice straight away. So what are some of the design considerations that we want to take into consideration when we do that?
Sure. I think that's a great question, because it's very important, right? That we focus on the correct design. We don't want to end up with a distributed monolith, right? So the first thing would be you want to make sure that your microservices are small, independent, and loosely coupled. Second, you want to make sure that your data handling is done correctly. You don't want to have a central database. Each microservice should be responsible for its own database as well as its own schema, so that if you change a schema for a microservice, you don't have to worry about changing other microservices. The next one would be intercommunication between microservices. I think that's a very important aspect of designing your microservices. You want to think about whether you want to do synchronous HTTP calls or asynchronous messaging calls. Understand your business application and decide what would work the best for you. The next one, imagine you have now hundreds, thousands of microservices. I think logging and monitoring would be very important to consider. So you need to have some central way of doing that. I think the last one, I would just say that although one of the biggest advantage we talk about for microservices is that you can choose like different technology or different language for each microservice, something you want to think about whether you still may want to restrict your choice of technologies versus just giving freedom to any team, because it can get complicated.
And so what you just kind of described there is that you got me excited about it and that we do have like freedom, but you also got me super scared because I think the complexity could ramp up super quickly.
Right.
So I'm gonna back up a little bit, and so let's talk about the small and loosely coupled microservice. So what we're talking about here is that one microservice, it shouldn't be dependent upon anything else. Is that correct in that regard?
Definitely. So here what we are thinking about is that let's say we made a change in a booking service for airline application. So when you change that, the other microservices don't have to change. If this microservice is scaling, the others don't need to do that. So they don't need to be aware of what's other. They call each other to run your application, but they don't need to change and scale. They can be updated. So you can update one microservice without updating others.
Oh,
so that's what we mean by.
And that's a really good point, is that you can just update one. So like your booking service, you can update that if you have like you're running a sale or something like that, or a new airline route becomes available. And you could scale that out. You can make it more available if you're getting a lot of inquiries or something like that, but not have to do that for another one because they're not related. So, and that's a benefit. Okay, so I'm not so scared right now. But but data handling. So you mentioned that each microservice now is going to have its own separate database because they are completely independent. Makes sense. It makes sense. So. All right, so I'm okay with that too. But that is a good point to drive home, and that's something I guess I didn't when I first started to learn about microservices. I always, cause you're coming from a monolith background, you just have like one big relational database sitting there. But that's different now, and you have to really consider having different ones.
Right.
But the inter-process communication, that it kind of gets tricky there, I think, where you're kind of, so I guess if you can explain like what's the difference between synchronous and asynchronous communication a little bit. When would I want to
Sure,
consider one?
definitely. So in monolithic application, you have all the components within, deployed together, right? So all the calls, you still have modules. So don't get me wrong, right? So we still have modular approach, still they are talking to each other, but these are all internal calls. So when we move to microservices, now they could be deployed, they are deployed independently. They still, to do the business logic, they still need to talk to each other. So we can decide how they are going to talk. So to make them really loosely coupled, asynchronous is a way where you call it and you don't have to wait for the response back from the other microservice. So you let it be. For synchronous, you make a call, but the calling microservice is still waiting for the response back. So if you can, I think asynchronous is more loosely coupled.
Mm-hmm. Okay, and that makes sense. And then the last point or you brought up was the I guess we'll call the technology freedom, where you give one team that can develop in, let's say, .NET or C# and another team's developing in Java, but that might not be such a great idea to let teams go all over the place for obviously a couple different reasons. In that, like, I'm not an expert in Java, and so if I had to help support an application in Java, it wouldn't be good. So I guess that's a good design consideration to take into account. So have you been on any teams where it's been like that, where you've had, I guess, a mess of different frameworks and languages?
Actually, from testing perspective, like for Acme here, so sometimes we have implementation of microservices using different technologies just to give it a try. So, but I do see that, like, you are hiring new employees which are much more comfortable with Python and other things, and they don't want to work in Java or other languages you might have, and that might be a good reason. Or you may find that the service you are writing could work more efficiently. You may be able to develop it more quickly in a certain language because you have libraries. So there could be very good reasons. But at least we have a choice of doing that if we decide. But in case of monolithic, we are tied to the runtime, we are tied to the same language.
Okay. So it's really, when we're talking microservices, it's like the dial. You're kind of making trade-offs between complexity versus simplicity, and you have to pick. You're not picking one, but you're kind of tuning in to how much complexity you want to accept versus how much benefit you can get from it.
I love the way you said, like, you have to see where do you feel the balance, right? When turning it on, there is not I think, a perfect solution for this. So you have to kind of start somewhere and play around with it.
Okay. So you work for Microsoft. I work for Microsoft, but you work for IBM. So IBM, you do testing there and work with the testing team, but does IBM have like any frameworks or tools that can help me out when I start building microservices that can make life easier for us?
Definitely. IBM has lots of products, but for our discussion today, I'll focus on a couple of products which I'm directly involved in. First, I'll talk about Open Liberty, which is a application server runtime. It implements microprofile, which is a great framework to write microservices, especially for Java developers. It's also very small footprint, great for running in containers, and actually you can run Open Liberty applications into Azure and other clouds. So we have actually blogs, and I have provided links for that as well. And also, there is an Open Liberty operator, which can be used to deploy those applications into Kubernetes. So the other one I talked about is mono to micro, which is for your journey from monolith to microservices. And we have another one for lifting and shifting your Cloud Foundry applications to OpenShift. And we also have IBM Cloud Garage methodology, which helps you, design your applications correctly for cloud as well.
Cool. And like Open Liberty is it's, as you mentioned, it's like an application framework. And what's cool about it is that you can containerize it, and then you can deploy it to essentially your cloud of choice, or you can run it on premise. Is that correct too? If you have your own application server.
That's correct. So you have a choice of running on-prem, or you can run on containers, cloud, different cloud providers, public, private. So yep.
And that's another great thing about these microservices is that you can, it's that dial. You can pick where you need to tune it in from, and they still can communicate wherever you need it from. And I have a question about mono to micro. Does it need to be Java based, or can it work with any framework?
I have used it in Java applications, and I'm pretty sure that right now it's for Java applications.
Okay.
But yeah,
I'm gonna have to relearn Java just so I can use it. I mean, it sounds super cool. I can't wait. So is there ever a time though, like, I guess there's a lot of fear of missing out when, like you hear the microservice architecture and you want to move to it, but sometimes you can't. And so would we ever want to keep that dial down to zero and keep it, or see, down to zero is a bad word, but keep it down to all the way to monolith? Like, so are there times when I want to stay with the monolith application?
I think there is, because if we are trying to solve a problem here. So if your application is small enough, working great for your environment, I would say don't worry about changing it. Or just we could, as we talked about, lift and shift, right? See if that works for you. Some of the other reasons people may not want to move could be security considerations, right? Now you have communication between these services, so you have to be aware of that. Or your team may not have skills yet to move to microservices, or your return on investment might be too high, so you have to, too low, right? So you have to consider those factors before moving to microservices. Okay,
yeah. So it's always you have to sit down and think about it before you just rush into it, because it could be too costly. The way the cost versus benefit, and the security concerns is a big one, because I used to work for a state government, and there is private data that you don't want to potentially get out there. And yeah, so that's definitely something you think of, because microservices do have to talk to each other. So, all right. So I made a decision. I want to go to microservices, but I have a monolith. So do I have to do everything at once? Do I have to move everything at once, or can I slowly start refactoring? So what's I guess not the process, but I guess, do I need to go all at once?
That's an excellent question, and I don't think that you have to go at once. So it depends again on your business application, how critical it is. There are different patterns to deal with the same. There is an interesting one for moving your application slowly. It's called Strangler Fig. This pattern is inspired by how fig trees grow. They start very small on top of a host tree and slowly grow and reach the ground. And once they reach the ground, they keep on growing and eventually kill the host tree. So this is something which can be, same pattern can be applied in this case, because now you are starting with something which are not as critical, right? Convert some parts into microservices and then slowly go through that iterative process.
Monica, you have me scared of microservices again now that they're going to strangle me and strangle my apps. But that's a good analogy, is that you don't have to go all the way. I mean, you can start, picking and choosing of what you have. And I guess one of the things that I've been thinking about as we've been talking is that you can go back if you needed to. You can start making your changes to one service. And I guess this is a question for you. I mean, do I need to stick with something? I make a decision to change, let's say, my booking service from, break that out of my monolith. But is there any reason why I have to, once I make my decision to jump to a microservice, am I stuck there? Or can I kind of bring it back in if I need to?
I would say you could, right? It's a matter of deployment, right? So if you had routed your traffic towards microservice, so for whatever reason it doesn't work, you could always route it back, right? That's the beauty of microservice, right? You can decide, even when you're making upgrades, you can slowly transition into your new microservice. So same way, I see your question the same way. If something is not working, you can just go back to your older way until you're ready to make the transition again. What do you think?
I think so. I mean, I guess one thing that I have a older house that I'm trying to slowly fix up, and one thing that I've learned is don't try to force something that's not working. Just don't keep on pushing through. Don't be afraid to back up and find out why whatever you tried to fix isn't working. Back up and see the real reason why. And I think you learn more that way if you try to uncover what might not be working.
I think that's a very interesting point. And I saw that some of the companies are going back from microservices back to monolith or macroservices. There might be a reason that you want to combine your services back into a bigger service again to avoid the overhead. Like if there are two microservices which are just calling each other, you may want to join them, make single service, so that they have now internal calls rather than overhead of inter services communication. So yep.
And I think that's a good point, is that you shouldn't be afraid to change things once you find out how things are working in the real world. Even though you sat down and you thought everything through, once you see it working, it might be different, so yeah. It's totally okay to evolve as you see your application in the real world.
Definitely.
Cool. So one thing that I thought of also is that when I was watching your presentation is we have things called functions, like Azure has Azure functions, which are just real tiny things. And microservices are real tiny things. So what's the difference between a function and a microservice? It's
right. We talk about both being focused on a small task. So sometimes the boundaries may blur on how small you want to do, but I see function as a small task which get triggered on an event, and also functions being deployed more serverless on a cloud, on a public cloud, where the cloud is taking care of all the infrastructure needs for your function. So you just go write your code and you pay as depending on how many times that is called, as opposed to microservices, which are more for a bigger business logic, as well as they can be running on premises or other places.
Okay. And yeah, so with a function, you're kind of tied with a vendor lock-in when you do it. Where a microservice, as we mentioned before, you can do it where it makes most sense for you.
Yeah.
And whether that's on-prem and in a public cloud or wherever. So it gives you a little bit of freedom as well.
Right. Like, for example, IBM Cloud has a way you can, define infrastructures for having your functions defined. So most of the cloud providers have a way to create functions.
Okay. And that's okay. That makes a lot of sense then. All right. So, so if we're looking, so kind of start wrapping up then. So if we're looking for microservices kind of is architecture where it's easy to develop because we can split it up. We can have a team that's totally good with like they're experts in that booking service and they're experts with Java, and we can have and they can deploy independently of another team that's, they do the image caching, let's say, and it's Python for whatever reason. I don't know what Python would do image caching, but still, and image caching can go completely separately. So that's a really nice architecture for it. But so can you give us like some key takeaways about the microservices or what you really wanted to drive home with your session?
Definitely. So if you want your applications to be easier to develop, deploy, scale, test, microservices is a good architecture to look into. But there are a few things we need to think about. First is why. Why are you even thinking about microservices? What problem you are trying to solve? Don't feel like you are staying behind, and that should not be the right reason for you to move to microservices. And see the problems, how they will be solved by microservices, and also what new challenges, design issues you need to take care of. So it's very important to do that analysis. The second point I want to make is your team culture and team structure ready for microservices? Because we don't want to have a big, tightly coupled team and work on microservices because it won't work effectively that way. So there is a term used which is like you should be able to feed 2 pizzas to your team which is working on a microservice. So you should be ready to have loosely coupled teams as well. So I would like to, just conclude by saying that you have to start somewhere when you're thinking about microservices. So see what makes sense. It may not be the most, small microservices where you want to be, but if you think you feel more comfortable at at some place, go for it. And this is something which will evolve over time as the needs of your business application evolve and change.
All right, that's cool. And I think we did spend a lot of time today, like talking about why you should consider microservices, but your session really did a good job of explaining, well, not only the why, but also the how of microservices. So it's really, really great to check out this session. And I know we'll put a link to it with the show notes for this talk. And so Monica, thank you very much for joining us today. I mean, I enjoy talking to you all the time, and I'm gonna be checking out Mono to Micro. That's a great tool. I love it. Just the idea of it. So great. Thank you very much, Monica. And glad that you could join us today.
My pleasure. Thank you so much, Matt.
Great. So April, what do you think? Should we put some microservices and some examples that we're building with Power Apps?
I think so. I think that'd be cool. And thank you for asking my burning question, the difference between microservices and functions. I was wondering that myself. So now that's all clear. So I'm happy. Cool. All right. Well, thank you to you both, Matt and Monica. And of course, I mean, this has been so fun. I don't know about you all, but I've had a really fun time here. We talked about so much stuff: microservices, predictive maintenance, process improvement. So I want to have a big special thank you to our guests, Monica, Banu, Sarah, and our cloud advocates, Cassie and Matt, for joining us in this conversation today. So if you're interested in learning more, be sure to check out our collection of resources on Microsoft Learn. The link will be in the show notes there, aka.ms/act-w/resources. And we also welcome you to participate in the Cloud Skills Challenge that we have going on until August 26th. So get your name on the leaderboard there and participate with that. Visit aka.ms/act-w/challenge to participate in that. And finally, of course, if you want to get more involved in the ACT-W organization and the community and support this amazing cause, be sure to check out their website, act-w.org, and sign up to become a member. Thank you again for all of the guests in this conversation, and we'll catch you next time.